everybody, Miss Burkett here. So today we get to do an experiment with water surface tension. Have you ever wondered about why a water strider can just run along on top of the water without sinking? Well, today you're going to find out. Okay, so I'm going to explain a little bit of what's going to happen because we're going to make a self-propelled boat. And so what you see here is on the top right, you see a water molecule, and that has two H's, that's hydrogen, and one oxygen, that's the O. And the way that molecule holds together, one end has a little bit of a negative charge, the end with the oxygen, and the other ends, where the hydrogen is, have a positive charge. So what happens is, when you look at the graphic there, the molecule that's in the middle of the water, it's trying to grab on. It's kind of like magnets where the positive and the negative ends are kind of trying to stick together. And so these molecules are just whirling around the water, and that force, that positive and negative force, is just kind of trying to grab onto everything that's around it. Top, sides, bottom. And so that is pretty evenly distributed. Now if you look at the water molecule that's at the top of the water, okay, there's water molecules below it, but there's nothing on the top. So the force that would normally try to grab onto the molecules at the top is now holding on just a little bit tighter to the molecules that are right next to it at the top. So that creates a little bit more tension, a little bit tighter grip between those molecules that are at the very top of the water. And that creates almost like a little trampoline elastic film. It's not super strong, and if you try to drop a nail on it, it'll sink. But the water strider is pretty light, and so if you go look back at the water strider picture, you can actually see little dents where the weight of the water strider is just kind of pushing down on that film, that surface tension at the top of the water, and making like a little dimple. And so that is water surface tension. Okay, so what we're going to need for experiments today is, so we have a bowl with water, and I have some dish soap, some black pepper, I have a pair of scissors, a couple Q-tips, and just a random piece of this corrugated cardboard. So those are the things you're going to need for the experiment today. Now if you want to, you can also make a little sail, because we're going to make a little boat. So I made a little sail out of a toothpick and some paper for mine. Okay, so for our experiment, here's our bowl of water, and then I have my pepper here. So I'm just going to sprinkle pepper all over the top of the water. And you can see how the surface tension of the water is holding the pepper up. It's staying on top of the water. Okay, so there is my bowl. So go ahead and get that ready. The other thing I'm going to do to get ready is I'm going to take a Q-tip, and I'm going to soak one end of this Q-tip with dish soap. So I have a Q-tip with dish soap. And we're going to hold it right here. Okay, get right there, pause the video, do the experiment, and then start it back up again. Because it's way more fun if you see the results without seeing them on the video first. Okay, are you ready? Here it goes. Okay, I'm going to put my dish soap soaked Q-tip in the middle of the pepper. What's happening? Look at that. So just putting the soap in there, all the pepper has moved to the sides of the bowl. And that is because where I added the soap, I actually lowered the surface tension, because now instead of the water molecules just trying to grab onto each other at the top of the water, they're trying to grab onto the soap as well. So that tension goes down, they now have more things to grab at. So the water surface tension is higher away from the soap, and so the
pepper moves towards the high surface tension area, sort of like when you release a rubber band, it just pulls it one way. So the pepper just moves from the low water surface tension area to the high water surface tension area. Okay, so now we're going to go on to the part that is my favorite when it comes to water surface tension experiments. So let's head out to a pond. Alright, so for our next part of the experiment, we're going to need the cardboard. So we're just going to cut a rectangle out of the cardboard. Once you have that cut, then you can go ahead and make a boat shape out of it. So here, I'm just going to cut my little boat front, and then I'm going to cut a little notch in the back, and that's where the soap is going to go. That's going to be our propellant. So here you go. This is your basic little boat shape. So you have kind of the front and the back. You just cut a little notch, and then I made my little sail for my boat. So there you go. My little boat is ready to go. All right, well, let's see if this boat will actually go. So, I'm gonna put it right in here. Just drop it straight down. There it goes. All right, as you can see, that boat actually went quite a long ways. I think it finally stopped going. But I really recommend you find a pond to do this experiment, because you will see your boat goes quite a long ways because it kind of runs out of soap. But the soap in the back of the boat lowers the water surface tension, and so the water surface tension is higher at the front of the boat, and so that higher tension is just pulling that boat along as the water is moving along from the lower surface tension area to the higher surface tension area. So that's what was making that boat go kind of like magic. So I hope you enjoyed the experiment. Yeah, go find a pond, do this, it's really fun. Bye bye.